मैं रिकॉर्डिंग कर लेना।
हाँ कर ले, स्टार्ट कर दे। स्लाइड दिख रहा है सर?
दिख रहा है।
ठीक। So good morning everybody. This lecture is kind of finishing lecture for your wireless and mobile networking course, and major emphasis would be on uh, developing application challenges. While you develop application in mobile and wireless environment, what challenges you can encounter. This whole lecture and every topic in itself is a very big topic. But what I have done, I have attempted to, you know, put together everything which can actually give you some pointers to think about. Many of you may include these pointers in your projects, and it can give you a complete idea that where our world is moving towards in terms of mobile application design. Now, you might have already seen, Professor Tyagi might have already covered the challenges you face while developing application at layer 2 and layer 3. So I'll be touching upon a little bit here just to tell you about what industry is thinking about these two things. What researcher and academician have thought about was already covered by Professor Tyagi. So you might have seen solutions like mobile IP and its variants. Sadly, it could not take off because of variety of reasons. There are solutions like Inter-Access Point Protocol, which is also named as 802.11f, which was later on removed from the wireless IEEE 802. Wireless standards. And then there are some proprietary solution, and one of these proprietary solution we have in our institute also, which is based on Cisco CAP. So I'll be touching upon each and everything. Beyond layer 2 and layer 3, uh, there are challenges related to TCP. We know that TCP connection can be identified by four tuple: source IP, destination IP, source port, destination port. And if there are any changes in one of these tuple, it may result in connection termination. So this is the point we are going to stress about. There are many solutions to handle TCP related problems in wireless and mobile environment, and Tyagi sir might have covered indirect TCP, Snoop TCP, MTCP, etc., and with all their problems and limitations. We're going to look upon two different proposals which deal with this problem, that how to keep these four tuple intact, and even if they are changing, how to hide and mitigate the effect of those things. So this is what we are going to see today. Now, as we know, the initial IEEE 802.11 standard suggests that it is break before make. When you make movement from one access point, wireless access point to another, so it breaks the connection before making the connection. That is the original definition of that. Now, it's not about access points. Access points can have this type of facility. Connections can be, the signal strength can be taken care of using beacon frame and all those things. And then you can break a connection and join to another access point. So we have frames, management frames like association frames, disassociation frames. When you disconnect, it's a disassociation, and when you connect, it is association. But the problem is something else. The problem is related to infrastructure switches. As we know that in infrastructure switch, this kind of table is there. So MAC address, port number, port name, and time to live. Now, if you see the condition here in this figure, this mobile node might be having one MAC address, and this is currently attached to AP1. So its MAC address is actually actually with AP1, and AP1 is connected to S1 Eth1. So right now the mapping of the MAC address of MN is with S1 Eth1. But when it moves, this mapping has to be changed. This mapping has to be changed. Means now it has to be MAC of MN should be attached to S1 Eth2. And until unless this is done, the packets which are coming from correspondent node will keep on going towards the old access point. And IEEE 802.11 standard was silent about this. Although in books you may find some material regarding that when it sends that association frame to this association frame can be forwarded to infrastructure switch. But the problem here is the association frame and everything is related to 802.11 and infrastructure switch is 802.3. So if you see any vendor specific access point, there is no provision of forwarding this association frame to the switch so that switch can update its table. Obviously, this is not a big problem because if MN is also sending some data continuously, then sooner or later this MAC table will be updated. As and when MN sends some data from under AP2, this MAC table will be updated. But it's a big problem when MN is in receiver mode. Suppose MN is watching movie and moving from one access point to another access point, and MN is not getting chance to send any data. Then this MAC table update becomes a big issue. And that was there, that is there from last 10-15 years. IEEE standard proposed a way out, inter-access point protocol, popularly known as 802.11f, where AP1 and AP2 can establish a UDP channel so that the data which accidentally have transmitted to AP1 may be forwarded again to AP2 so that they can be forwarded to the new location point of MN and to MN. And then there was a whole setup of this, that these UDP channel can be established. AP2 can notify the old attachment point that MN is now associated with AP2. A new type of management frame is utilized in this 802.11f, which can update the MAC address table of switches with respect to MN. So this was a good protocol, good provision, but it could not take off because vendors, various access point manufacturers and vendors were not interested to implement both network layer and transport layer functionality with the layer 2 functionality in access point. It was less cost effective. And another problem was how to integrate IAPP based access point with non-IAPP based access points. So this could not take off in 2008. This particular thing has to be removed from IEEE 802.11 standards. Another issue that was layer 2 mobility. Another issue is layer 3 mobility, where MN moves from one subnet to another subnet. And the challenge is network prefix change. Mobile node needs to change its IP address, which may result in termination of ongoing sessions. And you have studied the mobile IP concept, like we can have tunneling and things like that. But it's a very promising idea. Lots of variants of mobile IP arrived, but very few deployable product. And this issue of triangular and suboptimal routing. So if you see the current status, both IAPP and mobile IP are not there in deployable product form by any leading vendor. Fine. So the problem is there is no vendor agnostic solution. So what these big guns and big companies have done, they have come up with their own solution, proprietary solution, like SCAPWAP, Cisco Meraki, 45 Fortinet, Aruba. They came up with their own vendor-specific protocols and solutions, which are proprietary. To have a Wi-Fi network with mobility, with layer 2 and layer 3 mobility uh, in a medium scale, small to medium scale wireless enterprise networks. But the problem is that when you purchase this kind of solution, you have to purchase the APs and everything from the same vendor. Otherwise, means you cannot have a Cisco CapWap and 4540 net working together in the same enterprise because of dependency issue. So the challenge is to get a vendor agnostic solution that was not there. Cisco CapWap is a leading wireless enterprise network provider. Initially, it was LWAPP, lightweight access point protocol. And the things what Cisco has done has made everything very simple. The roaming, handover, authentication, security, etc., everything is shifted from your access point to a centralized controller. So access point in Cisco setting, in Cisco Cap Map setting, is just like a dumb device. If you can safely say it's a physical layer device which with a very little bit of MAC layer capability. An improved version of LWAPP was CapMap with a wireless, centralized wireless controller. And this particular thing which we have installed in our institute one and a half year back, it is still in first phase of implementation. It's a proprietary protocol, AP to AP transition. When you move from one AP to another AP is handled by wireless LAN controller. And MAC address table update in infrastructure requests are not needed. Why? We'll see just now. So even if you are moving from one access point to another access point, MAC address table updates are not required in Cisco CapWap. So what Cisco has done, it's just a big jugaad, fine. Uh, it's not like any based on any engineering principle. It's just like a jugaad technology, what Cisco has done. So I've just drawn here our institute network in a miniature form. So we have got this core switch 6509, and suppose with this core switch our two access switch 2960 layer 2 switches are connected. These are layer 2 L2 switches, and with this layer 2 switch our access points are connected. Cisco AeroNet 18115i. These access points we have connected. There is a centralized wireless controller, and there is a centralized DHCP server. So physically, if you see this is one physical subnet because it is connected to one port of our layer 3 switch, and this is another physical subnet. Means if a node moves from say this area to this area, this would be a mobile IP kind of thing because you are changing your subnet. Now what Cisco has done, that what you can do, you can convert or have a overlay of a unified layer 3 VLAN with obviously a different addressing mechanism. Means to implement CapWap, what we have done, whole institute wherever these access points are connected, and we have installed our own new L2 switches with the PoE, power on Ethernet capability. All these things, wherever they are installed in institute, are in one big VLAN. One big layer 3 VLAN, it means that they all are in one subnet. So whatever addresses are provided to the mobile nodes which are connected to these access points are from one subnet. So layer 3 mobility is not there. Now let's talk about layer 2 mobility. Fine. Suppose a node moves from here to here. Node moves from here to here. So in this switch, MAC table update is needed. But Cisco has safely avoided this thing. What Cisco has done, these MAC tables will be maintaining the MAC address of these access points only. So whatever node sends to the access point would be encapsulated by the MAC address of the access point, and then it will be sent to the switch. Suppose node moves from here to here and wants to send some data, again it will be encapsulated by MAC address of access point. And everything, suppose a node wants to send data to the node which is in same access point, still it will go back to the wireless access point controller and then come back to this node. So everything is getting handled by wireless controller because this particular device is a dumb device, is not having anything. Suppose a new node joins. This new node will send a DHCP request. That DHCP request will be encapsulated by this access point, will be sent to wireless LAN controller. A new node joins and sends association request. This association request will be again encapsulated and sent to wireless LAN controller, and this wireless LAN controller maintains a location database, that which node is currently connected to which access point. So suppose I want to transfer any data to any IP address of node. So my request will be forwarded to, encapsulated and forwarded to wireless LAN controller, and wireless LAN controller will see the destination IP address and will forward to that access point where the destination IP address or destination mobile node is currently available. Where it is currently available, it is also known to access point using this location database. Now what Cisco has achieved, because these access points are not mobile, they are fixed. So there is no issue of MAC table update, and all the MAC addresses of mobile nodes are hidden from the actual network. So Cisco cap map is only a big jugaad, fine. And jugaad is also a good word. It is in our Oxford dictionary nowadays, fine. Moving forwards, if there is any question, people can
सर
always interrupt me. Yeah.
सर डाउट सर
Yeah. बताओ.
सर ये सर when this mobile node is sending this sending its packet to the access point, and you said that access point puts its own MAC address, so does it encapsulate the entire DLL
Obviously.
packet, or
Obviously.
it just removes the MAC layer,
No, no,
the
it's encapsulate.
Acha,
Encapsulate.
okay. So it's
Oh,
just the MAC addresses of the mobile node is there, but it's just encapsulated inside the
yeah,
another.
yeah,
Okay.
yeah. It's a Ethernet over IP encapsulation. Okay.
Yes, sir. Thank you, sir.
EOIP encapsulation. Okay. Any other question? Okay. So moving forward, effect on TCP when you move. Change of endpoint creates problem. I told you socket level for tuple identification. If you change IP address, identification will change and connection will lead to connection termination. Another issue which Tyagi sir must have discussed, that TCP, our original TCP, takes loss of packet as implicit signal of congestion. Then and there it enters into congestion control, slows down the transmission rate, slow start will be started. And then there is another issue of retransmission. So when you are disconnected, you are trying to retransmit. That retransmission will also be not acknowledged. Then you will again retransmit. And every time you are retransmitting, your retransmission timeout will be doubled, almost doubled. So what may happen, even if receiver may get reconnected, at the another point, sender is still backing off because it is in the loop of that retransmission timeout. So this particular assumption that packet loss is due to congestion is very true for wired networks, but it becomes unreal for wireless network because most of the packet losses are mobility induced when you do handover from one point of attachment to another. And TCP enters into congestion control and retransmission mode. You are connected, you want to, because you were disconnected, you wanted to have more bandwidth as soon as possible, but TCP enters into sender enter into congestion control. And even if congestion control is there, this TCP sender is not able to transmit because of this RTO, uh, doubling of RTO every round. So these are the two issues which uh, need to be handled, because until unless your TCP, your transport layer is working fine, your applications cannot work fine. These things you have seen to handle packet loss, induce congestion control and retransmission, somehow hide the mobility induced packet losses.
मयंक
Sir,
वो सब्जेक्ट में हाथ खड़ा कर रहा है
हाँ? अच्छा वो हाथ दिखता नहीं मेरे को, मैं फुल स्क्रीन पे हूँ ना।
हाँ ये सब्जेक्ट में खड़ा कर रहा है हाथ
हाँ पूछ लो, सब तक पूछो।
सर आपने लेक्चर नंबर 7 पे आपने बताया था कि सब ऑप्टिमल राउटिंग होता है, एक और इशू ट्रायंगल राउटिंग के अलावा। हाँ सर वो क्या होता है सर?
सब ऑप्टिमल राउटिंग क्या होता है? बिकॉज तुम टनल ही बना के चल रहे हो, ठीक है। सपोज मैं तुमको बात करता हूँ, सपोज मैं और तुम दोनों ऑस्ट्रेलिया में हैं, ठीक है।
यस सर।
और हम दोनों का जो होम नेटवर्क है वो इंडिया में है। मैं तुमको डेटा भेजूंगा तो क्या होगा? हम दोनों होम नेटवर्क से बाहर हैं अपने अपने।
अच्छा हाँ
मोबाइल आईपी ध्यान करो, मेरा भी डेटा जाएगा इंडिया, फिर तुम्हारे पास आएगा,
इंडिया होके आएगा।
तुम्हारा डेटा भी इंडिया होके आएगा, ठीक है। और
अच्छा
होना
सर
क्या चाहिए
वही
था?
सब। हाँ सर समझ गए सर।
Okay. Anyway, fine. So this Professor Tyagi have taught you that somehow hide mobility induced packet losses, indirect TCP, freeze TCP, MTCP. In freeze TCP and MTCP, you use zero window advertisement. Fine. As soon as you detect the impending connection termination, or at layer 2, you inform the TCP. TCP will hold one acknowledgement and send a zero window advertisement to stall the sender so that you don't enter into that congestion control and all that thing. And here I just want to tell you one thing. I was not having much time. There are two proposals which came in 2012. Just for information, I'm telling. In 2009, first of all, one algorithm come known as EFL algorithm. Fine. And based on this EFL algorithm, I must just check the spelling. In 2012, spurious timeout detection was included in our RFC. Fine. So what is spurious timeout detection? The timeout which should not have happened, the timeout which is spurious, which is misleading because of mobility, the timeout has happened. So this particular two things was included in TCP specification. And nowadays, if you talk about nowadays Linux kernel after 2015, Linux, and I'm not very sure about iOS, but Linux and Windows kernel have included this particular facility of spurious timeout detection, where once you detect the spurious timeout, which is not due to actual packet loss, which is due to some any other reason, you can retrace the TCP connection state and start the TCP connection from the state from where you have reduced the TCP connection, congestion window and all those things. Fine, you can roll back the TCP connection state if you detect the spurious timeout. This is getting included in our Linux and Windows kernel. Not sure about iOS and Mac OS. But all the ideas are related to this, that somehow hide. First step is hide the mobility induced packet losses, and second step, let the losses happen which are mobility induced. But if you know that these are mobility induced losses, roll back to the initial state. Fine. These are the two approaches which have been there in our TCP side. Another thing which is endpoint issue, how to handle endpoint issue. Two very interesting proposals came into picture, uh, and based on them, nowadays enterprise networks are behaving. Migrate TCP and MSOCs. So what is migrate TCP? It's very simple. You know about TCP options, like we can use SAC option, window scaling option, and then there is that power against wraparound sequence number option. Fine, where you can send a 32-bit timestamp in TCP option field. So these options known as SOC ops, fine, socket options, which can be negotiated at the time of sending SYN packets. But okay, my end is going to use this particular option. So on the same lines, a migration support option was proposed during initial connection establishment. This migration support option can be negotiated during initial connection establishment. What it does, it gives a token, and there is a whole lot of theory behind this token. I'm not going to into detail of that. You can get a number and then hash that number, and that number token number is negotiated the hash of initial sequence number with some random value so that it cannot be hacked by some eavesdropper. All those things are there. So this token is there which identifies the connection. So instead of 4 tuple, we have this is there, 4 tuple is there, but we have this migration token also as an identification. So what it does, this 4 tuple are there, but this migration token, identification token is already there. Suppose I draw this, suppose there is a sender. So a receiver is here with IP address 1, and suppose receiver changes to IP address 2 after the movement. And during this, when receiver moves, there are options that sender can be stalled. So even if you change your IP address, you can use this token that, oh, no, I'm the same connection, which was there on IP1, the same connection is there on IP2. And during this time, you can use TCP keep alive to maintain that connection. This connection may not be terminated. So we can do some tweak here at keep alive, fine. And when it again rejoins to different IP address, it can utilize this migrate token to inform the sender that, okay, I'm the same client, but right now using different IP address. Fine. Upon migration to new address, send a new migrate SYN with the earlier token. That's what I was telling. So that old connection can be continued. When one endpoint does not hear from another, we enter into another state known as migrate wait state. Remember in TCP, there was a time wait state. Similarly, we can have migrate wait state for possible migration before timing out and closing out the connection. So this was very interesting proposal. Could not be implemented it at TCP level because you require bit of changes at TCP. You required having socket option, but that was still I don't understand the reason. This paper was published in 1999, and many fellows have referred to this paper as a viable solution. But why it could not took off, uh, I don't have any reason behind that. It was a very valid suggestion. Another is MSOX. Uh, you people know about SOX proxy?
नहीं सर.
एक बार देख लेना SOX proxy. जैसे HTTP proxy होता है वैसे SOX proxy होता है. Fine. थोड़ा सा change होता है. So this SOX, based on SOX proxy, MSOX was proposed. This is getting utilized in some setup for and use cases where mobile hosts within the organization are there. We can have a TCP proxy at the edge of organization, which handles all the TCP connection behalf of mobile client and hides mobility from the remote host. So what is happening? Suppose there is a proxy, there is a correspondent node, and mobile node is moving in the organization from one access point to another. So the mobile node is always connected to this proxy. And this proxy is connected to the correspondent node. So ultimately you have two TCP connections. One between proxy and correspondent node, another between proxy and mobile node. When I want to connect to another node, I would be always going through the proxy because I am moving also. Now you move anywhere, now there would be no problem. Even if you change your IP address and do all those kind of things, you are not directly communicating to the correspondent. You can always inform the proxy that I am from that same session. So what is happening? The mobile host gets a connection identifier, same like migrate. Look how migrate was utilized here. Shown to the proxy when they move. So they get when they first join, they get a identifier. When they move, they'll again show that identifier. I'm the same chap. Fine. Mobility is simply handled by opening a new connection on the mobile side. Fine. A new connection will be made to proxy. This proxy maintains the state of the old connection. Fine. Unsplicing connection to the old IP. Old connection would be removed. This connection will be unspliced. And resplicing new connection to the remote server. And this proxy will maintain a new connection to you. So in this way, using a proxy between correspondent node and mobile node, and using MSOX proxy, you can do all those kind of things. Obviously, just a minute, I have to take this call. बोले अभी ज्वाइन कर लेना. सोना वाइवा है बेटा संस्कृत का तुम्हारा. संस्कृत का वाइवा है बेटा. अभी तुरंत मम्मा ने लिंक भेजा. हम तुमको फॉरवर्ड कर रहे हैं तुम्हारे मोबाइल पे. Sorry guys. Huh? So obviously you need to do some changes in connect and accept system calls to implement this new connection and new splicing and old splicing thing. हाँ मैं क्लास ले रहा हूँ 1 मिनट रुको त्यागी सर 5 मिनट मेरे को थोड़ा सा दे दीजिए हाँ। त्यागी सर 5 मिनट ब्रेक लेता हूँ सर हाँ, हाँ। अब डिस्टर्ब नहीं करना हमको क्लास ले रहे हैं Now, after doing this, sorry for the interruption. After doing this, let's move to the actual issue of our lecture. I have just included these things for the completion. Um, Application layer. How can we do the mitigation at the application layer? We know these things that your mobile devices are going to be resource poor. Not nowadays. They've got good smartphones and all. Less secure, vulnerable because of wireless connectivity. Poor connectivity and mobility are related. That you may get the connection, you may not get the connection if you are moving, and that this is the biggest issue, the energy, because they all are battery operated most of the time. So what is the solution? Solution is only one: dynamic adaptation. In normal settings, when you design an application, so there is a certain amount of quality of service negotiated or quality of experience negotiated, that okay, this application will provide this quality of service. Before designing application, you negotiate this thing with your client. But in mobile environment, this particular thing happens continuously because your context keep on changing. Less connectivity, less battery, good connectivity, good battery. So your context is dynamic. So you need to do dynamic adaptation, and this QoS may be renegotiated. You can always talk about minimum and maximum QoS. You cannot talk about the QoS. You can talk about, okay, I will give this minimum quality of service or this maximum quality of service, and QoS may be negotiated and renegotiated as per the situation. This is what is the challenge at the application layer. So we'll pick each and everything. Way out, the most obvious is prefetching and caching. So there is a whole study which is related with, and I don't have time to deal with that, known as disconnected operations, where you know that disconnections are going to happen. So how we can deal with this disconnected operation? There is a whole set of theory and implementation related to this. So there are file systems, there are separate file systems which handle these. So I'm not going into detail of that, just giving you some pointers. Prefetching and caching: fetch and cache the content when connected. If you have good connectivity, suppose you are watching movie and you get good connectivity, save for the future, buffer as much as possible so that it can be utilized when you are not connected. This requires cross-layer interaction because your physical and MAC layer are going to tell that, okay, there would be impending disconnection. Right now you have good connectivity, so fetch and cache as much as possible so that it can be utilized when you are not connected. Code or computation offloading, Siri does the same. Fine. That the compute intensive stuff can be offloaded to cloud. Fine. And you don't do compute intensive things at your mobile phone or your mobile device. Those things can be offloaded to cloud. Again, it's very tricky. Agile QoS agreement, as I told you, will provide services according to context and available resources. So these are the way outs while you design application layer of mobile. Energy saving, biggest issue, and whole lot of research is involved in this. Whenever you go and purchase a mobile phone or any wearable device, any smart device, the first question you ask, uh, what is the battery life? Fine. You do this thing at physical and Mac layer. Your radio sleeps uh, and deploy power save mode. Fine. So physical and Mac layer are already doing this thing that they you sleep and wake up for energy saving. But just see the downside. When you are running TCP over 802.11 power save mode, it can lead to increased delay in getting acknowledgements because the radio is sleeping. And if you are in slow start phase, then that connection will take longer time. That particular thing will take longer time to download data. And which can negatively impact the energy saving. So the things are really tricky. Fine. So and that's a major research objective in front of designers. How to save energy at application layer? Energy spent can be classified in two types. Energy spent on I/O, so radio, GPS, Wi-Fi, screen, and energy spent on computation, rendering web pages on browser, computing the moves, future moves in games, speech recognition. So when you play a game, what would the future move that has to be computed? When you download a web page, connect to a web server, web page rendering is there. When you speak something and somebody wants to recognize your speech and use Alexa or OK Google or Siri, then this is the issue. That means you need to do computation. Biggest problem is this radio tail energy. Even after the transfer is complete, the data transfer is over, your radio is in high power state for some time. And this is known as radio tail energy. Suppose you are downloading a file, your file is downloaded. Fine. Still after download, your 3G and 4G radio, in 4G it's a bit less, in LTE it's a bit less, but they keep in high power state and they spend a lot of energy, which is known as radio tail energy. This is the biggest challenge. Energy and I/O. Now see what are the problems. I/O activities happen in bundles with wait time between bundles. When you do WhatsApping or do something, because you think and then write, you think and then you play, you think and then you type. So you transfer data, there is a gap, again transfer data, there is a gap, and so on. Your application also can space out I/O to limit the rate limit the bandwidth. Now, the gap between these bundles are actual source of radio tail energy, because you transfer data, radio tail, you waited, again transfer data, again radio tail, again transfer data, again radio tail. If that data transfer might have happened in one go, there would have been only one radio tail. So this particular issue and this balancing, every application and every mobile operating system designer is trying to have. When you close a TCP connection, you just send a FIN message. It's a very small data transfer, but it is again involved with the radio tail. That is actually described here. The code that closes idle TCP connection incurs the penalty starting the radio for a short period of time to send the FIN message and incurs the radio tail energy again. Problem: radio energy for data transfer is less, and for radio tail it is more. Solution is you need to group together IO activity, group together these IO activity to reduce radio tail energy as much as possible. Think over it, all these issue for 5 minutes, 3 minutes, and if there are any question you can ask.
सर ये ग्रुपिंग का मतलब कि ये गैप्स में जो है उस गैप्स में भी कुछ आईओ यूज करना है.
Any questions?
सर ये ग्रुपिंग का मतलब कि ये जो गैप्स बन रहे हैं आईओ इवेंट्स, तो उस इवेंट्स में भी कुछ और आईओ इवेंट करने का.
हाँ, कुछ आईओ इवेंट डाल दें या आपको बताएं कि आप व्हाट्सएप कर रहे हो, ठीक है, फिर आप आंसर कर रिप्लाई कर रहे हो, या you are thinking and writing, fine. So instead of sending whatever you have written for little amount you have written and sending then and there, what you
So
can
you
do, you can
buffer
buffer
a bit
it,
and
send it. So these kind of optimizations are getting done, and there are very nice papers by Apple designers and Android designers are available, which if you want I can share it with you. So I'm just trying to tell you the overall problem, fine, just to make you aware about the issues. Anyways, energy on computation. Browser spend energy on parsing and rendering JavaScript and CSS. You decompress images from JPEG to BMP or so on for display. Other apps spend energy in computation, speech recognition, or computing future move of games. Two ways to reduce computation in browser. Front-end proxy at mobile service provider that can optimize the web page for mobile. And here comes the context information. So how a web server and content delivery network provider, so a movie in 3GP format looks good on mobile, but it does not look good on tablet. So for mobile, 420p is enough for video streaming, but for tablet with bigger screen, high resolution, 420p may not be good. So how these things can be done intelligently, this is the issue, and this can be handled if your mobile subscriber knows what device you are currently using, what is your current bandwidth, what is your resolution, so the web pages and the content can be optimized for your device. Rendering low resolution images suitable for web browsers. So that's why when you develop a so you can see that there is a difference between m.facebook and facebook.com. You might have observed this, that when you have Facebook on mobile and Facebook on mobile, using Facebook app on mobile and running mobile on Facebook, Facebook on mobile using browser, and running Facebook on a tablet or running Facebook on desktop, all are having different versions. And we say that this particular website is mobile responsive or not, or something like that. Now this is most common thing, offloading some computation code to remote server. And this is most suitable for voice recognition kind of apps, the voice command apps like Siri's and all. Fine. Code offloading. Voice recognition features Siri in the iPhone. Nowadays it is possible because we are having 4G. We can quickly send the piece of the voice sample to a remote Apple server. Code can run there and results can be transferred back to your mobile phone very quickly with less amount of delay due to good connections. Voice sample from phone is analyzed and passed on remote Apple servers in order not to consume resources on phone. But there is a trade-off. Remote computation will save CPU cycle and hence energy and processing time, but network transfer will consume energy. Depends on how much code to exchange and may add to latency. And this is again a very, very huge research area. Fine. That what should you do? Code partitioning should be manual or automatic. Automatic with some intelligence. Intelligence means network कैसा है, अच्छा है कि खराब है. Intelligence means अभी मोबाइल फोन में रेजिडुअल सीपीयू साइकिल कितना है जो यूज हो सकता है. मैनुअल तो मैं फिक्स कर दिया कि ये काम बाहर ही होगा, ये काम अंदर ही होगा. Automatic with some intelligence is depending upon the context. If you are on Wi-Fi, send it to remote server. If you are on 4G, आपका पैसा खर्च होगा. Don't send it. Compute it here. If you are using Siri and at that same time doing some heavy computation, send it to remote server. But there are issues. You cannot offload the code that depends on your I/O, camera, etc. So for that, you need to run the code here in the mobile phone. Little bit of some application development platforms, more so Android. I know many of you are familiar with the Android app development. This is just for the completion so that people who have not seen Android and coded on Android platform may find out the difference. If we see the journey, traditional model of computing, we have OSs, Linuxes or Windows, libraries, APIs, and applications. Then comes the era where applications are hosted remotely, accessed by desktop via browser, your cloud-based applications. If you see 10 years back, 10 or 15 years back, 10 years back rather, mobile application also followed traditional desktop principles. Before this Android thing, we used to have our embedded Linuxes and Windows ME platform and all that. OS and application customized to run on different resource challenge platforms. Fine. Initially, mobile application also followed the same principles. But now with the smartphone, which are having good computation and good uh, battery power and good connectivity, the model of mobile application is changing. How it is changing? Android and iOS are the main players. We'll focus on Android. Now, if you talk about the Android ecosystem, which is basically Linux, some extra libraries, Android runtime virtual machine, Dalvik VM, application development framework, which is interesting. Application development framework. I'll come back to this. And your application. Anyone can develop an app using framework, any of the Linux libraries. We have got desktop version of Android Studio also, where you get the same environment the way you get on a mobile phone. Applications are written in Java and run on Dalvik virtual machine, which is nothing but an optimized JVM. Traditional environment, if you talk about, users are the main entities and they are bounded with permissions. User ID, group ID, and blah blah. In Android, each app has its unique ID. And each app runs in its own separate Dalvik VM. Means if you are running 20 apps, they will be all running on lightweight virtual machine. Fine. So they are not running on a kind of native OS kernel and taking services. They are running on separate virtual machine. This enforces isolation and allows to run untrusted third-party application, because even if a app is misbehaving or trying to do some mischiefs, that can be confined to one virtual machine and may not be able to play with your native Android. Interesting point here is mobile app development. You are not making system or application for a specific client. You are making it for general janta. So your whole software engineering approach is different. So you are not going to target a specific client. The client is coming to your company and you are making an application for that. You are targeting whole set of communities and so your point of view in designing application changes. There is a fixed structure of Android application. That's why I was saying that application development framework is same, fixed structure. And you need to conform to this fixed structure. There would be user interface, service interface for background processing, data store, and mailbox to receive notification. And this fixed structure actually helps in easy development of apps. You are not required to think about the framework. You just need to think about your module. What is going to be my user interface? What is going to be my backend? Where the data comes from, and how I can get notification from different entities. In Linux, we use IPC, inter-process communication, like shared memory pipes and sockets. In Android, it is known as intents between component of application. What is there in intent? As an argument, target component and action. So an intent in its argument can tell what is the target component and what actions are going to be performed. Component that receives the intent does the action described in the intent. Can start activity or service, can bind to a service, can send a query to content provider, something like that. Intents can be explicit, which gives the target, or implicit, where Android identifies a suitable target. The important point is Android reference monitor, which checks for the permission. Which checks for the permission. Means module cannot talk to each other, fine, until unless they pass through the reference monitor. And for external communication, this is same as Linux, using network sockets, Java libraries, and so on. Access control in Linux is provided by setting permission based on user and groups. In Android, every component is protected by permission label. These labels can be defined by system or app developers. If you want to access one component want to access using intent, another component may have to have a required permission. For sending intent, for receiving intent, both permission are needed. And all these checks are enforced by reference monitor, where in addition to checking intents, access the network, camera, etc. are also enforced. Many type of permissions: harmless, dangerous, and system permission only for system apps. ये हम लोग ध्यान नहीं देते कभी, अपन लोग जब ऐप इंस्टॉल करते हैं तो सब कुछ पूछता है ऐप से. This app want to access your content, this contact, this app want to access your camera, this app want to access your GPS location, and you generally you approve everything. But these are dangerous. That's why you have to approve them. There is a manifest file which is related with the application, which declares all the components and permission. This permission can be granted at the install time. It asks, this app wants this app wants this app wants. And you generally don't read them and allow all, and you're done. Let's take an interesting use case finally to tell you about where we are moving towards. This use case may not be very much, you can say, relevant in our Indian context. But yeah, these kind of use cases are getting deployed and getting attempted in foreign countries, and they are moving towards that. So this part is already there. Remote communication, RPC, ACID properties, two-phase commit, nested transaction in your databases, distributed databases, fault tolerance, HA servers, replication, rollback recovery, high availability, distributed file system, distributed databases, caching for remote information access. Just add CDN to this content delivery network. Distributed security for encryption, mutual authentication. So this all is there in distributed systems. What mobile computing adds? Mobile networking, mobile IP ad hoc networks, wireless TCP fixes, disconnected operation, and weak consistency. These two aspects one should always study. Adaptive application, I have given a brief idea about that, using proxies, code offloading, agility in QoS negotiation. Energy aware system and location sensitivity, GPS and all that, context awareness. When you add all these things to distributed system, you come to mobile computing. And we are in this era, pervasive computing, where there are smart spaces, invisibility, localized scalability, uneven conditioning. We'll be coming to this in a short while from now. Pervasive computing means computing is getting done on variety of platforms and it is invisible from you. It is invisible from you. That is like pervasive computing or ubiquitous computing. So we are in this era, fine, and that's why we talk about IoT, sensors, fine, and mm, various other aspects. I'll be coming to that. So this is the use case. Suppose I have planned to go to movie after office, say on Friday, say 9 p.m. to 11 p.m. show. I have booked ticket in advance and got the ticket on my app or email. That app is or email is having permission to update my calendar. So my Android and iOS calendar knows this, that on Friday 9 p.m. to 11 p.m. I'll be going to watch the movie. My vehicle also know this because my iPhone is synced with the onboard unit of my vehicle. See the information flow. You booked a ticket, you got a notification or mail, your calendar is updated, and your vehicle knows this because your OBU of your vehicle, onboard unit of your vehicle is synced with your phone. Your vehicle is in parking, which informs the parking management server that my lot or my location or my vehicle parking spot is going to be vacated for sure at that time between 8 p.m. to 11:30 p.m. Now see here, your show was 9 p.m. to 11 p.m. Movie location, movie theater location, your location is known to your phone and your OBU of vehicle. Vehicle inform the parking management server that 8 बजे से 11:30 तक ये खाली रहेगा. पिक्चर 9 बजे से है, इसने 8 बजे बोला. पिक्चर छूट रही है 11 बजे, इसने 11:30 बोला. यहां भी इंटेलिजेंस लगाया. कैसे अभी बताएंगे. Now this can be shared, this particular information can be shared to other vehicles for their own purpose, that एक parking lot है वो खाली रहेगा 8 से 11:30 बजे. How it can be shared? My vehicle has contacted the ITS Intelligent Transportation System Cloud, which has results of predictive analysis, which knows that around 9 p.m. the traffic condition would be like between my location and movie hall would be like this, and calculated the traveling time. See, at 8 p.m. it takes 1 hour, at 11 p.m. it takes 30 minutes. Are you getting my point or not? Fine. This can be shared with my phone to inform me about the departure time. Fine. So everything is getting done and you have just booked a movie ticket. Everything is getting done, and this is known as a smart spaces. So your phone contacted your vehicle contacted your parking server, your vehicle contacted your ITS cloud. That ITS cloud is doing predictive analysis, knows about the traffic condition at that time, and gave you the estimated time and blah blah blah, and then it informed you that picture देखने जाना है 8 बजे निकल लेना. Fine. Now another thing, my phone informs and gave one suggestion that it's better to depart at 7, 8 बजे मत जाओ. Because at 7 you can reach there in 45 minutes. At 7:45 you do have a party at home on Sunday, and the item list is also on your phone, and in your calendar, you do have a party at home on Sunday. There is a sale going on in supermarket near movie hall, and those items which are there on your phone can be found there. And luckily, the parking lot on supermarket is also vacant 7:50 p.m. to 8:30 p.m. You can purchase your stuff and then head for the movie. Are you getting my point or not? So this is where the use cases are coming up. There are devices everywhere. There are smart devices everywhere. Fine. Now, this is pervasive and ubiquitous computing. To realize these type of use cases, we need pervasive or ubiquitous computing environment on roads, where objects, vehicles, roadside units, etc., can make their microprocessors available. They can be woven into a smart fabric leading to a computation and communication infrastructure on road, which is apparently invisible to the users. This is where we are moving towards. Any questions from anybody? Okay. Issues. When you talk about in this manner, pervasive computing manner, in traditional internet, IP addresses serve as an identity, and then we have domain name system to solve the problem of identity and reachability. Now here is the challenge of providing unique identity to millions of smart devices. Yeah, IPv6 can do these things. But again, for all these millions of devices, you have to have DNS to locate, and so that's not possible. Fine. It's difficult to locate the device of interest for data sharing among lot of available devices, because the use case I told you required so many devices working in tandem, generating the information, generating the traffic information, maintaining information at ITS cloud, generating information from the parking lot, maintaining information, updating it on parking server, and all these servers are, connected together to give user a better experience. Dependency over cloud. Continuously transferring data, all the data to cloud is costly, wasteful in terms of bandwidth. And all the applications cannot tolerate the latency introduced by, because you are dependent on internet. Internet is having all it's the best effort delivery service due to reliance on centralized computing. So these are the issues for these use cases, these type of use cases. The identity of devices, dependency over cloud. So where we are moving towards? We are moving towards computing at the edge. I'll tell you, your smart oven uses ARM and MIPS processor, which can easily run your Python programs. Your router or access point is also a computer, which is having a microprocessor. Algorithms are running, and not every time it is transferring your data. Not every time it is transferring your data. So a hell lot of CPU and memory is getting underutilized. These devices can serve as edge computers, which obviously, centralized cloud computing you cannot avoid. You have to have some permanent storage where to do predictive analysis and things like that. And there are lots of mobile phones around, which those CPU cycles can be utilized. Obviously, challenges are there. So why should I allow my mobile phone to be utilized for whose purpose? For our purpose, but for the community purpose. Another problem is, which is the communication partners which want to communicate are decoupled. It is not like a server is there and a clients are contacting to that server because we know that server will be always available. Here you want to take information from a vehicle which is here at this time, maybe somewhere else at another time. So the communicating entity or communicating partners are not there at the same time, may not be connected at the same time. So there is a deep coupling between communication partner. So we want a paradigm which can give you decoupling, asynchrony, and anonymity. We are interested in data, not in device. I just want data, traffic data. I'm not interested which vehicle is giving me that traffic data. So these are the requirements. Fine. The edge type of computing, a computing communication paradigm. Obviously, our network substrate should be having these properties with self-configurable, self-healing, quick to deploy, scalability, efficient resource discovery, dynamic leaving and joining of participating entities. So which kind of network is coming in your mind? Anybody? Underlying network, which kind of network can do this? Obviously, wireless network substrate. Yes, anybody? What should we have at the network level? Where it is not sure somebody is there or not, where entities are moving. Which kind of network?
Ad hoc networks.
Ad hoc network, yeah, Manas, ad hoc network. And because in this use case, we are talking about vehicles, so we have to have a spatial type of ad hoc network, which is vehicular ad hoc network. Am I right?
Yes, sir. Yes.
So there are existing technologies to fulfill the needs. Edge computing, coined by IBM, fog computing, coined by Cisco. They extend cloud-based services to the edge network. Can be easily used in the context of a smart environment on roads for providing cloud type of services with less latency. And here comes our computing or environment, or which is also known as microservice. Fine. In cloud, we talk about virtual machine. There are virtual machines which are assigned to the subscriber. In edge, we need to talk about containers. You might have heard the name of Docker. So the code offloading, which I am telling, so to run the code of speech recognition, you need execution environment also, which is there on cloud. So your Siri voice sample goes to Apple Cloud because Apple is having that environment to run that code. You need the environment also to run the code. If you, first of all, the edge computing devices would not be having enough memory and computing power to hold your complete VM. So there is an alternative to VM which is known as container. In Linux, we have LXC, LXD, all these containerization technologies. Or I don't know whether computer science fellows have done this, but मानस तुम लोग को मैंने वो पढ़ाया था ना नेम स्पेसेस
Yes, sir. MiniNet and named spaces.
Namespaces. So we can have namespaces or containers which popularly Docker is a platform for that nowadays. But you can use directly Linux containers also, which where you can run your execution environment along with the code, and these codes can be assigned to the edge devices on demand basis. It is just like the way your normal operating system does. In OS, there is a RAM and then there is a hard disk. So in operating system, what you do demand paging. You bring the component or piece of code page wise on demand whenever it is needed. Similarly, we can have container repository somewhere, and on demand we can call the containers to be run on these edge devices. Fine. So this is what is the existing technology which can fulfill the need of the use case we have discussed. Another thing is paradigm. We require a paradigm where it is not required to have the communication partners available at the same time. We can have asynchronous paradigm, popularly known as publish subscribe communication paradigm. And you might have heard these names: MQTT broker, data distribution services, AMQP protocols. So it's just like this. So there is this event-based system. There has to be some broker. It can be, this broker can be centralized or distributed, or there can be no broker also. It is just a higher level abstract view of publish subscribe. There can be information providers which can publish that मेरे पास ये है जिसको लेना हो ले ले information. They don't know who is going to use this information. There can be consumer, subscriber, which subscribe for the information. So whenever it is available, please tell me. I don't know whether it is available right now or not. And then there is a event service where you have subscriptions from the consumers, you have publications from the publishers, and this event service does the storage and management of subscription and match with incoming publication. And then notifies. Hey, जो तुम चाहते थे is available now, you can take it from this publisher. So this is known as implicit invocation system. And that is not only for the data item. That can be for your, you might have heard about RPC, remote procedure call, and RMI, remote method invocation, where you certainly know that this procedure is available on remote PC. I can remotely execute. I can call a procedure which is remotely available. I can invoke a method which is remotely available. You certainly know in RPC and RMI. In implicit invocation system, you don't know whether that particular procedure is available. You just subscribe for that procedure. And you have to have a non-blocking kind of control flow. That you require something to be executed, you subscribe for that particular module, but you are not blocked. You can keep on going. This is known as flow decoupling. You don't wait for that particular thing. You design your application in such a manner. And whenever that particular code is available or published by somebody, you can take that piece of code, execute it, and you are done with that. So this kind of communication paradigm is needed. Existing technology, I told you, VANET. Fine. Where the vehicle, roadside stations, the sensors set traffic signals, all combine together, work together, GPS, fine. The ad hoc network, the 3G network, all combine together to when you talk about this kind of system, there are two things, data acquisition, data transference, how to transfer data, and then data analysis. So these three things are getting done by these devices. Hop by hop transfer, decoupled environment, delay tolerant features, dynamic topology, fine. And all those things are there in VANET. Communication paradigm, I told you that message passing, remote invocation are not robust enough because they are inherently tightly coupled, where they assume that partners are available all the time. In our type of use case, frequent joining and leaving, a paradigm shift is needed in the manner users communicate with each other. And this is what I told you about publish subscribe. Final words regarding mobile application and pervasive application design is adaptability. Devices are heterogeneous in terms of processing power, I/O capability, network bandwidth, memory and energy capacity. Not only heterogeneous, this heterogeneity is not fixed. A device may be having high bandwidth at one given time and low bandwidth at another given time. And application and services have to adapt to current resource availability. This is what you need to have at your application layer. Final words, context awareness. So I've put down so many points here. I'm just reading it out. So I've discussed about this. Services may adapt the content they provide to the according to the context of the client. Adapt stream video to screen size. Adapt encoding to the encoder which are present at device. Compress the content to reduce the bandwidth. Have performance enhancing proxies at mobile service provider. Content adaptation on the fly, increased set of permutation of client and services. You can think of a peer-to-peer network where in a BitTorrent fashion that a movie is not getting downloaded from a single source. A movie can come, part of movie can come to different sources, and from there you can have a community type of thing. You can send black and white images instead of color images if your bandwidth is very low. Fine. So all these kind of thing can be done at the application layer, knowing that layer below are susceptible to mobility and disconnection and all that thing. Lastly, where we are moving towards and going to move towards. This is the current state of the art. If you see your mobile phone, like if I take my mobile phone, these are not mere mobile phones anymore. They're damn smart devices having very advanced operating system. Like I've named Jelly Bean, Kit Kat, Marshmallow, and so on. iOS, every 6 months there is a new version. Lots of computing power, dual quad octa core processor, and lots of memory. त्यागी sir, त्यागी sir. सर आपने पहला पीसी जो खरीदा था वो आपके मोबाइल फोन से ज्यादा पावरफुल था.
अरे पावरफुल क्या था उसमें फ्लॉपी लगती थी एक 1.4 MB 1.4 क्या था वो
1.4 MB
MB की एक फ्लॉपी उसमें लगाते थे हम लोग.
एक पेंटियम 5 होता था.
MB में ही मेमोरी होती थी.
So that's what I'm trying to say. Even the routers at that time, the routers we used to have, are having less power than these mobile devices. So we are not far away from vision of autonomic cloud created in ad hoc manner. This use case I have seen in Barcelona.
और वो जो MB में मेमोरी होती थी उसे रखने के लिए हार्ड डिस्क इतनी बड़ी होती थी कि वो सेफ में आती थी पूरी. हम लोगों के पास उस कंप्यूटर एक फ्लोर पे पूरे केवल सेफ रखी हुई थी जिसमें हार्ड डिस्क रखी जाती थी.
नहीं वो सेफ अभी भी रखी है अनिल सर के कमरे में.
अनिल के कमरे में अभी भी वो सेफ है.
ये बच्चा लोग आएगा तो इनको दिखाएंगे कितनी बड़ी हार्ड डिस्क होती थी. So we are not far away from the vision of autonomic cloud. This use case I have seen in Barcelona. In metro train, in a metro train, there used to be like 200 passengers average. All are having mobile phones. All are having Wi-Fi. Fine. So they were trying to run the songs on the speaker of metro using the songs available on these fellows' mobile phone. So this is what? It's a cloud which is created in ad hoc manner to provide storage, computation, software as services. So we are not far away from this. Vision of volunteer computing infrastructure using underutilized computing, storage, memory power of a smartphone. I don't know whether you have heard this term or not. We tried to use this. This is known as crowd sensing. It's not crowdsourcing, it is crowd sensing. So if there is any event somewhere, your mobile phone is having many sensors, accelerometer and this and that. And if the sensor data of those mobile phone can be forwarded to some analytics engine, we can actually calculate the crowd density, seeing the accelerometer sensor data, that how much crowd is there because their movement is less. This is just some idea I'm trying to give it to you. So this crowd sensing is also a very important thing which is not very much far away. So with this I have done. I'm done with my lecture and I'm happy to answer any question if there are any. Any questions from anybody? ठीक है त्यागी सर फिर.
हाँ ठीक है फिर बंद करते हैं. चलो फिर ठीक. हैंग अप करते हैं.
ठीक.